Analysis in machine learning is a statistical technique used to measure and understand the strength and direction of the relationship between two variables. It plays a crucial role in various stages of the machine learning workflow, including. Here's a breakdown with examples. 1. Feature selection. Identifying redundant features. If two features are highly correlated, one of them might be expendable, as they likely provide similar information. Example. In a housing price prediction model, square footage and number of rooms might be highly correlated, so you might choose to keep only one of them. Detecting multicollinearity. This occurs when multiple features are strongly correlated, causing instability in models like linear regression. 2. Data exploration and understanding. Uncovering hidden patterns. Correlation analysis can reveal relationships you might not have expected, leading to new insights and feature engineering ideas. Example. You might discover that customer satisfaction correlates positively with response time to support tickets, suggesting a potential area for improvement. 3. Model evaluation and interpretation. Assessing feature importance. Some algorithms, like linear regression, provide coefficients that indicate the relative importance of features, which can be influenced by correlations. Understanding model behavior. Analyzing correlations between features and target variables can shed light on how the model makes predictions. 4. Model debugging. Identifying potential issues. Unexpected or counterintuitive correlations might signal problems with data quality or model bias. Common correlation coefficients. Pearson correlation coefficient, R, measures linear relationships between continuous variables. Values range from 1, perfect negative correlation, to +1, perfect positive correlation, with 0 indicating no correlation. Spearman's rank correlation coefficient, ρ, measures monotonic relationships, where variables consistently change together, but not necessarily linearly. Example of correlation analysis in machine learning. Customer churn prediction. You might find a strong negative correlation between customer churn and customer satisfaction scores, suggesting that improving satisfaction could reduce churn. Key points. Correlation does not imply causation. It only measures association, not whether one variable causes changes in another. Correlation analysis is often visualized using scatter plots and correlation matrices. Correlation analysis is a valuable tool in machine learning, but it should be used in conjunction with other techniques and domain knowledge to draw meaningful conclusions.